Well, hey, look at this right here. What we have right here is an example of a single bond, which is what we kind of started talking about last week. We got our introduction into writing Lewis structures, and here's a Lewis structure of hydrogen selenide. So we've got hydrogen, two hydrogen atoms bonded to one selenium atom, and we see that if we draw the Lewis structure for that, it looks like this. We've got a single bond here and a single bond here. And last week we learned about how a single bond is essentially just two shared electrons. So this bond right here is made up of two electrons. So if I were to actually redraw this like this. So we've got these two electrons here, one electron from selenium, one electron from hydrogen, and these two electrons here will spend some amount of time around hydrogen and they'll spend some amount of time around selenium, and that way hydrogen can get its full valence shell with two electrons, and so it's happy, and selenium, because it needs two more valence electrons. It's getting one from hydrogen. It's getting another one from this hydrogen over here, and so then it has 8 electrons around it, which is what it wants. And so that's what we were learning about last week. So we've got the single bond, which is composed of 2 electrons that are shared between these two atoms. But wouldn't you know it, we can also have double bonds and triple bonds in these. So I know this sounds like exciting stuff, and it is. So let's not waste any time here. Let's talk about this. So let's look at an O2 molecule, a molecule that is composed of 2 oxygen atoms that are bonded together. If we look at oxygen here, if we draw the Lewis dot structure for oxygen, oxygen has, if we go to the periodic table and we find oxygen, oxygen has since it's in the 16th column here, we know that it has 6 valence electrons. And so I'm going to draw 6 valence electrons. 1, 2, 3, 4, 5, 6. There's 6 valence electrons that oxygen has to work with. Now we've got 2 oxygen atoms in this molecule. 1, 2, 3, 4, 5, 6. These two things are going to form a bond. So I've got oxygen bonded with oxygen. So we can think about it as maybe this, these two electrons here are going to form a bond. And so these two electrons we can think of are in this line here. And let me put the rest of these electrons that we haven't used around each one. Now, if we look at this, though, let's count up how many electrons are around each oxygen. Because remember, what they're trying to do here, these atoms are trying to get 8 electrons around them. They want to have 8 electrons in their valence shell so that they feel stable. Let's count how many electrons are around this oxygen here. 1, 2, 3, 4, 5, 6, 7. Because remember that these two are shared between these. So these 2 electrons can count towards this one. So 1, 2, 3, 4, 5, 6, 7. It's only 7. And same thing for this guy over here. 1, 2, 3, 4, 5, 6, 7. They each only have 7 electrons. They want to have 8. And so how we can satisfy that octet rule is basically we can think of 1 electron from here and an electron from here are going to form another bond. And this is where we can get the double bond. So let me get rid of these electrons here. That electron and that electron. Because now they have become this bond here. And now we can go through and count up how many electrons are around each one. 1, 2, 3, 4, 5, 6, 7, 8 for this guy, and same thing for this guy. 2, 4, 6, 8. They both have 8 electrons around them, which means they're both stable and they're happy. And the only way we could do that was by putting 2 bonds between them. Let's take a look at an N2 molecule. If we look at this one, nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. And we're going to bond that with another nitrogen. 1, 2, 3, 4, 5. Okay, if we bond these, so let me just do it one at a time. We got a nitrogen attached to another nitrogen with a single bond. And so let's imagine that it's these 2 electrons that are bonding together. So I'm going to put the rest that are left around it, like that. And if we count up how many electrons are around each, 1, 2, 3, 4, 5, 6. Each one has 6 electrons around it. They want to get 2 more around it. So what I'm going to do is I'm going to use this guy and this guy to make another bond here. And I'm going to get rid of this guy, this guy. Let's count them up again. 1, 2, 3, 4, 5, 6, 7. I need to get 1 more for each of them. And so I'm actually going to make a triple bond now. So it's like I'm taking this electron and this electron to form another bond. Now I've got a triple bond between these 2 nitrogen atoms. These are now here. And now if we count, and actually let me redraw this. These 2 would actually be over here like this. Now let's count them up. So for this nitrogen here, I've got 2, 4, 6, 8. Same thing for this guy. 2, 4, 6, 8. They both have 8 electrons in their valence shell, and now they're stable. So as you can see, we can not only have these single bonds between atoms, we can also get double and triple bonds depending on what is being bonded. And they're basically doing that to satisfy that octet rule, to try to get 8 electrons in their valence shell. So let's get a little more practice drawing some Lewis structures that involve single and multiple bonds. I know last week we kind of did like a real quick introduction to this, but now we're going to go a little more in depth on how we do this. So let's draw the Lewis structure for a real simple one, NH3. So the first step in doing these Lewis structures is the first thing we're going to do is we're going to find the total number of valence electrons for the whole thing. So it's like we're counting up how many valence electrons in total for 1 nitrogen and 3 hydrogens. So here's how I'm going to do that. Nitrogen, I see that I've got 1 nitrogen, so I'm going to put 1 times how many valence electrons nitrogen has. Nitrogen has 5 valence electrons. Again, I get that from where it is on the periodic table, so it's in column 15. So it has 5 valence electrons. So 5 valence electrons, and then hydrogen. There's 3 atoms of hydrogen, so 3 times, and hydrogen has 1 valence electron. So I've got 5 times 1 is 5. I've got 3 times 1 is 3. 5 plus 3 is 8. So I have 8 electrons total, 8 valence electrons total that I'm going to use in this structure. There's going to be 8 total that I should be able to count up. No more, no less. Okay, so now the next step. Determine the number of bonding pairs. So this is the total number of electrons that I have to work with, but how many pairs, how many bonding pairs do I have to work with? And the easiest way to do this is just to divide the total by 2. Just divide the total by 2. So I've got 8 total valence electrons divided by 2, which means I'm going to have 4 pairs. So I'm gonna basically, once I get done drawing this, I should be able to count up 4 pairs of electrons. So third step, now that I've determined how many electrons I have to work with and how many pairs I should have, now I can place some bonding pairs between atoms. So we've got 1 nitrogen and 3 hydrogens. And sometimes you might get a little stuck thinking, well, what atom how do I draw this? What atom do I put in the center? How do I know how to draw it? And for figuring out what atom goes in the center, typically it's going to be the one with the least amount. That's not always the case, but the one that has the least amount in that molecule. So nitrogen only has 1 atom, so it's probably going to be the central atom, and it's going to be surrounded by these 3 hydrogens. Also, the thing with hydrogen is never in the center. It's never the central atom because it only has 1 valence electron and can only hold 2 valence electrons in its outer shell, so it can never be in the center. It can't hold that many valence electrons. So if we've got something with hydrogen in it, we know that the hydrogens are going to be around the outside, and that whatever it's bonded with is going to be in the center. So for this, these hydrogens have to be around the outside. So I'm going to put nitrogen in the center. And so I'm just going to put 1 bonding pair to start with. I'm going to put 1 bonding pair between the nitrogen and the 3 hydrogens. So I'm just going to draw it like this. And again, you might be like, well, how do I know to draw it like this? What if I drew it like this? Or what if I drew it, maybe I wanted to draw it like this? How do I know it's not going to be like this, right? And that's a valid question, but at this point, I'm not too worried about how you're starting off like this. So let's not worry too much about the way you're drawing it like this. I'm only worried about your placement of electrons at this point. So don't worry about too much. Don't put too much emphasis on trying to figure out how to draw it like that. Like if you were to draw it a little bit differently than how I would have drawn it. So if you would have drew it like this or like this, that's not that big of a deal at this point. So don't worry about it. Anyways, so I've got my structure here. I've got nitrogen in the center. I've got the 3 hydrogens around the outside, and there's a bonding pair in between each one. So now let's figure out in step 4 here. It says determine how many pairs remain, and we're going to place the remaining pairs around the terminal atoms. Here's what that means. We said that we have 4 pairs of atoms to work with. I have 4 pairs of atoms to work with. How many do we use? 1, 2, 3. So that means I have 1 more pair that I need to put somewhere in here. But I don't have any more hydrogens to bond. I only had 3, right? It's NH3. I only had 3 hydrogens to work with, so it's not like I can put another hydrogen in there because I don't have another hydrogen to work with. So what we have to do is we're going to have to put on some what are called lone pairs. Lone pairs of electrons are electrons that aren't attached to anything. They're alone. So what I'm going to do is the first thing we do is we're going to put those around the terminal atoms. Terminal atoms are the ones that are on the ends. So these hydrogens would be terminal atoms that are along the outside. But hydrogen, we never put any lone pairs on hydrogen because, again, hydrogen can only fit 2 valence electrons anyways. So this hydrogen already has 2, this hydrogen has 2, and this hydrogen has 2. So I can't fit any more electrons on these hydrogens. But I can fit electrons on the central atom here. So what I'm going to do is I've got this. I need to put 1 more pair of electrons somewhere, and the only place I can put them is on the nitrogen. Right there. And now, last step, determine if the central atom satisfies the octet rule, and if it doesn't, then we got to start converting our lone pairs into double or triple bonds to try to make it work. Well, if I count this up, if I look at nitrogen here, it has 2, 4, 6, 8 electrons around it, and that satisfies the octet rule. And all the hydrogens also satisfy that rule because they have 2 electrons around them, which is what they want. And so this is done. This is what the Lewis structure would look like for NH3. Let's try another one. CO2. So our first step, figure out how many electrons total, valence electrons total that I have. Carbon, there's 1 atom of carbon here, and each atom of carbon has 4 valence electrons. Oxygen, there's 2 atoms of oxygen. Each atom of oxygen has 6 electrons. So 4 and 12. So we have 16 total electrons that we have to work with in this molecule. Let's figure out how many bonding pairs there's going to be. So 16 divided by 2. I'm going to have 8 pairs. 8 pairs are going to show up in my final thing. All right, so again, let's draw out what our basic structure is going to be. I've got 1 carbon and I've got 2 oxygens. So now there's no hydrogen in this one, so you might ask yourself again, how do I draw this one? Which one goes in the center? Well, there's only 1 carbon and there's 2 oxygens, so it's probably going to be carbon in the center, we can assume, and it's going to be surrounded by 2 oxygens. Another thing you can use to help you is that typically the element that is furthest to the left, on the periodic table is probably going to be the central atom in this case. That is going to be the central atom in this case. So if we look at carbon and oxygen, carbon is further to the left on the periodic table, so it's probably going to be in the middle. So let's put carbon in the center. Carbon in the center, and we're going to have 2 oxygen atoms attached to it. All right. So we've used 2 pairs, and I have to use a total of 8. So that means I got to put 6 more pairs of electrons on there. We're going to start with the terminal atoms first, which in this case are the oxygen ones. Carbon's the central one. Oxygens are the terminal ones in this case. So I'm going to start adding pairs to the terminal ones first. So remember, I used 2 pairs. I got to use 6 more. So there's 1, 2, 3, 4, 5, 6. Okay, there's my 16 total electrons, or my 8 pairs. Right, so if I were to count them up, 2, 4, 6, 8, 10, 12, 14, 16. Or 1, 2, 3, 4, 5, 6, 7, 8 pairs. So there's all my electrons. I'm using them all. And so now the last step is I have to make sure, does the central atom satisfy the octet rule? And no, it does not. Because if I count it up here, I've got, this carbon has 2, 4 electrons, and that's it. It needs to get 4 more electrons in order to have 8 around it. So now what I have to do is I have to start playing around with this and seeing if I can get some electrons to form maybe a double or triple bond to get 8 electrons around carbon. So what I'm going to do is I'm going to take this pair of electrons here and I'm going to put it here. So these 2 electrons now become a bond between carbon and oxygen. And so now if I count it for carbon, now it has 2, 4, 6. I need to get 2 more electrons. I'm going to take it from this oxygen here. It's going to become a bond here. So now what I'm going to do is I'm going to get rid of these guys because they've now become a bond. And now it satisfies the octet rule because now carbon has 2, 4, 6, 8 around it. And oxygen still has 8 around it, right? Because this oxygen has 2, 4, 6, 8. And so does this guy. So now they're all satisfying the octet rule. I have 16 total electrons in the whole thing. And so that's the Lewis structure for carbon dioxide. Let's do one more just for fun. C2H4. C2H4. So in this one, the first step, let's figure out how many total electrons. Carbon, I have 2 atoms of carbon. Each carbon atom has 4 valence electrons. Hydrogen, there's 4 of them, and I have 1 electron in each. 2 times 4 is 8. 4, there's going to be 12 total electrons. 12 divided by 2 tells me there's going to be 6 pairs. Okay? Let's put, again, hydrogen can never be in the middle. So in this one, it's going to be 2 carbon atoms in the center surrounded by 4 hydrogen atoms. So I'm going to put 2 carbon atoms in the center. And now I've got 4 hydrogen atoms. So obviously we're going to want to balance this out, right? I'm not going to try and put I'm not going to have 3 hydrogens here and 1 hydrogen here, okay? It would make more sense to have 2 on this carbon and 2 on this carbon. So that's what I'm going to do. I'm going to put it like this. Okay, so I've got a single bond between each one. I've got a single bond between each carbon. I've got a single bond between each carbon and each hydrogen. So I'm supposed to have 6 pairs. I've got 1, 2, 3, 4, 5. So I need to put another pair somewhere. We're supposed to start adding it to the terminal atoms, except for hydrogen. Hydrogen is my terminal atom in this case, so I can't add any more electrons to those. So I have to add electrons to the central atoms. Well, I've only got 1 pair that I have to get rid of. So I just got to pick one of these. So I'm just going to pick this guy here, and I'm going to put that lone pair of electrons on carbon. So now I've got 1, 2, 3, 4, 5, 6. 6 pairs, 12 total electrons. Now, last step, I count up and see if the central atoms here satisfy the octet rule. So for carbon, 2, 4, 6, 8. So this guy has 8, but this guy doesn't. He only has 2, 4, 6. So I'm going to have to do some rearranging here. I'm going to put this pair of electrons as a double bond between these 2 carbons. And if I do that, now they should both satisfy the octet rule, because this carbon has 2, 4, 6, 8, and this carbon has 2, 4, 6, 8. Each hydrogen has 2, and so this is the Lewis structure for that one.